So this next unit is going to explore agriculture, and really specifically how we do agriculture here in the United States, and some of the associated problems with that type of agriculture. This is an incredibly huge topic because obviously agriculture is what the world depends on. This is how we are getting all of our nutrition, whether we're eating, crops directly or we're eating animals which are fed our crops. And so there's different strategies around the world, and they do all sorts of different things. We're going to focus on, at least in this first video, on fertilizers, how we use fertilizers, why they're used, and how we could use them differently. So there's two major types of agriculture. The first type of agriculture is what we do here in the United States. We have a very industrialized agriculture. We don't use that much cropland. About a fourth of the country is used as cropland, or I shouldn't say of the United States, but really around the world. Only about a fourth of our usable land is used for crops, but because of this industrialized agriculture, it actually supplies about 80% of the world's food. Now, it's considered industrialized because if you see in this image, tons and tons of machines, we can do this on a very wide scale. It's also because we do monoculture. So monoculture, if you look at this word, so mono meaning one, and then culture like agriculture. So monoculture is we are cultivating usually one crop. So in this picture, this looks like it might be hay or something. In this case, we are harvesting one crop. We are growing one crop in this entire field. But obviously multiple farms growing different crops. The other type of agriculture is a traditional subsistence agriculture. Subsistence means that you are growing things really for yourself or for your family. You're not really making more food and selling it or giving it away, so to speak. So if you're subsiding, you are taking care of yourself. And this type of agriculture is typically a polyculture. So here we have that root poly. Poly means many. Now the reason it's many is because, if you're growing this for yourself and for your family, you don't want to eat just one type of food. You want a variety of foods. So this is why it's typically a polyculture. We also see this a lot in the developing world where industrialized agriculture hasn't really taken over. And so people have to rely more on themselves and more on what they are producing themselves. Now, the traditional subsistence agriculture is typically better, at least for the environment, but as you can imagine, it's not making that much food, and this would require everyone to do, which isn't really a possibility. So we're going to explore more just into these types of agriculture. Now, as I mentioned, with our industrialized agriculture or our practices here in the United States, there's a lot of problems, and we're not going to talk about all of these problems, but some of them we will dive more into. In this lecture, we're going to talk a little bit more about fertilizer. We'll also talk about pesticides and genetically modified organisms, and then we'll briefly touch on monocultures, erosion, and water, but really focusing on fertilizer and pesticides. So you're probably familiar with fertilizer. You've heard it used before. If you have a garden, you may have probably used fertilizer before. You've probably heard of Miracle-Gro. We use fertilizer for pretty much all of our crops or flowers or really anything that we're growing. And for good reason. It works. If you look at this image, this is looking at a cornfield. You're looking at plants right here that has no fertilizer on it, and plants right here which does have fertilizer. You can see the ones with fertilizer are nearly double the size of those without fertilizer. So as you can imagine, really important to our crops. And that's fine. The use of fertilizer itself is not bad. The fertilizer is in no way harming the plant. However, we may have some other issues. Now, fertilizer isn't just fertilizer. It's actually a component of a whole bunch of different things. So fertilizer, typically when you buy it at the store, it's going to give you 3 numbers. So if we look at these bags, we've got these 3 numbers and these 3 numbers. Those three numbers relate to the amount of chemicals that are found in those bags. Or not amount of chemicals, but the proportion of those chemicals. The three chemicals we will find are nitrogen, phosphorus, and I'll show you why I'm doing that in a second, and potassium. These are referred to as NPK. K is the chemical symbol of potassium on the periodic table of elements. So what farmers and what regular people are looking for in a fertilizer is their amounts of NPK. So for example, this one. This fertilizer bag has 16% nitrogen, 20% phosphorus, and no potassium. Whereas this one has 28% nitrogen, 6% phosphorus, 6% potassium. Now, no, that doesn't equal 100 pounds. All the other stuff in it is kind of just a filler and some, like a little bit of extra things. So I mention this because the type of fertilizer you put on your land is incredibly important. You know, if you are doing an actual planting, you want to give your plants whatever it's missing. Maybe your soil has tons of potassium, so you're not going to give it more. Or maybe your soil has tons of nitrogen. Well, you don't want to give it more. And so it's really, really important to be getting fertilizer that matches the kind of soil you have. The unfortunate thing is that is very rarely done. And that causes problems in not just the United States, but really around the world. So the way plants grow, related to these elements, the way plants grow is that whatever is the lowest, if they don't have that much nitrogen, it doesn't matter how much phosphorus you give them, it doesn't matter how much potassium you give them, the plant will not grow unless you give it nitrogen. Now this principle is referred to as Liebig's law of the minimum. So his law of the minimum says that whatever is in the lowest demand or the scarcest resource, whatever is the lowest, that's going to prevent that plant from growing. Until you give it that resource, the plant won't grow. So why this is important is, so this one shows potassium. So imagine that this is a plant. A plant. So imagine this is a plant. And it needs all of these things. It needs calcium and zinc and magnesium and hydrogen. It needs all of these things. And I've given it all of these things. And let's say I get a fertilizer that has tons and tons of nitrogen. So I'm going to make this bar even higher. And it also has lots and lots of phosphorus. Well, that's cool. I mean, plants do need that stuff, but if I don't give it any potassium, that doesn't matter. The plant really needs that potassium. Until I give it potassium, that plant's not going to grow. So if I don't give it any potassium, it's just not going to grow. If I give it more potassium, then it has the ability to grow more. Now the reason this matters, this probably seems like common sense to you, the reason this matters is if you do not get a fertilizer that is specially designed for your type of soil, we get this happening. So this is on a farm after a really heavy rain, and you can see runoff. And runoff is kind of a natural part of the ecosystem. But as you might notice, this runoff is not clear. It's kind of a blue-green color. And it's not because there's plants in it. There's fertilizer in it. You know, these plants, in this case, you know, they really needed K. They really needed, you know, potassium. But the fertilizer you put on there had tons of nitrogen and tons of phosphorus. Well, the plants can't absorb that nitrogen and phosphorus. They can't absorb anything until they're getting more potassium. They can't use that other stuff. So what happens is that nitrogen and phosphorus just stays on the ground. And during a heavy rain, that nitrogen and phosphorus is going to run off these fields, phosphorus is going to run off these fields into this water and continue going. So where does it go? Well, this water will eventually go to a larger water source, so maybe a small stream, which will go to a larger water source, like a larger stream, into a large river, and finally into the Gulf of Mexico, to the East Coast, to the West Coast, to really the largest body that is around, whether this is in the United States or anywhere around the world. So because of the principles of Liebig's law of the minimum, we're having way too much fertilizer entering our ecosystems because we are not giving the plants exactly what they need. We give them a lot more of some other stuff, and that other stuff has nowhere to go except out with the water when it rains. So the reason this matters is this is good fertilizer that works for land plants, but it also works for aquatic plants. And algae love fertilizer. Algae are related to plants. Algae need nitrogen and phosphorus and potassium too, and you just supplied them with it. So all of this green stuff that you're seeing, this is algae. Remember, algae is one of our producers in our ecosystem, particularly our aquatic ecosystems. But you can see, how much algae is growing. Here's, a canoe, so a huge, we call these algae blooms. But here, this is a small boat going through this huge algae bloom. So it's like a really, really big thing. Now, this might be good in the short term. These are more producers, right? That means it can feed more primary consumers and secondary consumers and so on and so forth. And it does, but we'll kind of talk about some of the effects afterwards. Now, these algae blooms are caused through a process called eutrophication. So that's what this word is down here, eutrophication. Eutrophication is the increase in nutrients. So this is increase in nutrients. So the nutrients, nitrogen, phosphorus, potassium, whatever ran off of those fields, are eutrophifying or providing nutrients into this ecosystem. And the effect of that would be these algal blooms. Now there is a really cool video that kind of shows like a real algal bloom in China. The algal blooms happen around the world, but China's had some crazy algal blooms in the past. So go ahead and pause the video, watch this YouTube video that should be popping up, answer the follow-up questions in the weekly guide, and then come back and resume this.